Hello everyone, welcome to our basic calculus class. This is our recorded session for the limits of exponential, logarithmic, and trigonometric function. So let's start with the concept of exponential functions. Recall that exponential functions are functions of the form f of x is equals to b raised to x, wherein b, okay, referred to as the base, is a positive real number. So guys, there are two possible values of b, okay? Number one, b greater than 1 or positive numbers guys greater than 1. So example 2, 3, 4 up to positive infinity, okay? So if that's the value of b, meaning the graph is strictly increasing. Okay? So the second possible value of b, ito naman yung second case natin. So b values that lies between 0 to 1, meaning decimal numbers or fractions between 0 to 1, okay? Like 1.5, 1/3, 1/2, okay? So if it's the value of b, meaning the graph becomes strictly decreasing. Okay. So again, in case where the base, okay, is equal to e, that's an Euler's number. Okay. Meaning we have a natural exponential function. Okay. So in terms of the limit of exponential functions, due to the nature of the graph of the exponential functions, the following concepts are true. Number one, for any real number, a, the limit of b raised to x as x approaches a is equals to b raised to a. So, ano meaning nun? So, meaning guys, you can just substitute the value of a into the given exponential function to get the limit. Okay? So, for problems wherein x approaches positive or negative infinity, we need to consider the following concepts, guys. For b greater than 1, the limit of the exponential function as x approaches negative infinity, okay, if the value of a or c is negative infinity, guys, the answer is automatically equal to 0. Okay, and the graph becomes horizontally asymptotic to the x-axis. Now, for problems wherein the limit of an exponential function, okay, as x approaches positive infinity, but positive infinity naman, the answer is positive infinity. Okay, and then the y value becomes increasingly large as x becomes increasingly large. Okay, now, for decimal or fraction values, no, or number that lies between 0 to 1. So, the limit of that exponential function as x approaches negative infinity, this time babalikan lang natin. So, if x approaches negative infinity, the answer is positive infinity. And then, if the limit, okay, or the limit of an exponential function as x approaches positive infinity, this time yung answer naman dito ay 0. Okay? Now, this time, let's try to solve or find, okay, the limits of an exponential function. So let's open our discussion board. Okay, so let's try to answer the following examples. Okay, so anyways, for limits of exponential function, again, according to our presentation, we are allowed to apply direct substitution. Okay, so let's open our discussion board for exponential function. Ayan. So sagutin natin itong mga examples na to, okay? Examples letter A to J. Now, example number 1, okay? The limit of 7 raised to x as x approaches positive infinity. Okay, right now, x approaches positive infinity. So, kung mag-a-apply tayo ng direct substitution, this one will give us 7 raised to x or positive infinity. Again, if that's the case, the answer is automatically positive infinity. So, for b greater than 1, okay, automatic na yan yung ating pinaka-final answer. Okay? Now, how about example letter B? The limit of 7 raised to x, wherein x approaches negative infinity. Right now, yung c or yung a value natin is negative infinity. So, let's apply direct substitution. This one will give us 7 raised to negative infinity. Okay, that's a very small number. So, again, the answer is equal to 0. So, that is according to our concept no sa ating presentation. So, b greater than 1, if x approaches negative infinity, the answer is automatically equal to 0. Now, another example, example letter C. How about limit of 5 raised to x? The base is 5, and then x approaches negative infinity. So, again, same procedure. Let's apply direct substitution. This one will give us 5 raised to x or negative infinity. So, let's substitute negative infinity. Again, the exponent right now is a very small number or negative infinity. The answer is equal to 0. So this is our final answer. Next, how about example letter D? How about limit of e raised to x? Okay, that's an Euler number, guys. Okay, and then x approaches 0. So right now, x is a specific number, guys. It approaches a specific number. Okay, let's apply direct substitution. So this one will give us e raised to x, or again, the value of c or a, that's 0. So again, e raised to 0 is equals to 1. So that is according to the limit laws, okay? So kung yung exponent ng some specific value ay 0, automatically the value is equals to 1. Except for 0, okay? Except for 0 raised to 0. So that is our final answer. Now, example letter E. How about limit of 0.2 raised to x? Okay, where x approaches positive infinity. Okay, x approaches positive infinity. So right now, the base is a number that lies between 0 to 1. Okay, so let's apply direct substitution. So this one will give us 0.2 raised to positive infinity. Okay, so sabi sa ating presentation, for numbers that lies between 0 to 1, if x approaches positive infinity, the answer is equal to 0. Okay, kabalit na lang yan ng previous concept for b greater than 1. Right? Now, how about example letter F? Okay, example letter F. How about the limit of 1/2 raised to x, and then x approaches positive 2. Okay, x approaches positive 2. Now, guys, I encourage you to pause this video and then try to answer this problem. Okay, so let's double check our solution. So limit of 1/2 raised to x, and then x approaches positive 2. So this time, let's apply direct substitution to answer this problem. So 1/2 raised to x to 1/2 raised to the constant, which is positive 2. Now let's simplify. What do you mean by 1/2 raised to 2? So according to the laws of exponent, guys, 1/2 raised to 2 is equal to 1 raised to 2 all over 2 raised to 2. Okay? So yun yung meaning ni 1/2 squared. Okay? So again, just simplify. 1/2 squared, or 1 squared is equals to 1. That's 1 times 1, and then 2 squared, that is 2 times 2. The answer is equals to 4. So meaning 1/2 squared is equals to 1/4. So this is the limit of 1/2 raised to x as x approaches positive 2. Next, example letter G. How about the limit of e raised to x minus 2, and then x approaches positive 2. X approaches positive 2. So guys, please try to answer this example. Okay, this time, let's double check our solution. Okay, so let's apply direct substitution. So this one will give us, again, e raised to x minus 2. So let's substitute 2. So from x to positive 2, and then copy the remaining term minus 2. Now let's simplify the exponents. 2 minus 2 is 0, meaning this one will give us e raised to 0. Again, e raised to 0, according to the laws of exponent, if the exponent is equal to 0, automatically the answer is equals to 1. Meaning, the limit of e raised to x minus 2 as x approaches 2 is equals to 1. Next, example letter H. So again, guys, please try to pause or try to answer this problem. I-post natin yung video, okay? So limit of 2 raised to negative x minus 4 raised to negative x all over x as x approaches negative 2. So x approaches negative 2. So please try to answer this problem. Okay, so let's double check your solution. So again, let's apply direct substitution. So right now, the constant or the value of a is equal to negative 2. So let's substitute, okay? So this one will give us 2 raised to negative x, or negative of negative 2, okay? Minus 4 raised to negative x again, or negative of, again, the constant negative 2. And then copy the denominator x. So let's substitute x, that's negative 2. Okay? Now, let's simplify the exponents, okay? So, negative of negative 2 meaning, okay, 2 consecutive negative signs, so magiging positive. So, that is equal to 2 raised to 2 minus 4 raised to 2 all over negative 2. Okay? So, let's simplify. 2 squared is equals to 4 minus 4 squared is equal to 16, and then the denominator is negative 2. So, 4 minus 16 is equal to negative, okay, that's negative 12 all over negative 2, meaning negative divided by negative, the final answer is positive. So the answer is positive 6. So guys, please double check your own solution. The answer is positive 6. Next example. How about example letter I? The limit of 5 raised to 2x minus 1 as x approaches positive 2. X approaches positive 2. So, okay, let's double check your solution. So let's apply direct substitution. Okay, so this one will give us 5 raised to 2x, or 2 times the constant again, that is 2, and then copy the remaining term minus 1. So let's simplify the exponent. 5 raised to 2 times 2 is 4, and then copy the remaining term minus 1. 4 minus 1 is 3, so we have 5 raised to 3. So let's simplify. 5 raised to 3 is equal to 5 times 5 and times 5. So the answer is 125. So this is our final answer. So that's the limit of 5 raised to 2x minus 1 as x approaches positive 2. Next, example letter J. So again guys, please try to answer this problem. I-pause natin yung video and then let's double check your solution later. Okay? Alright, so let's double check your solution. So limit of 1/2 raised to x minus 1, so that's the exponent, plus 1/4 as x approaches positive 1. Okay? X approaches positive 1. So let's answer this problem. So let's apply direct substitution. So we have 1/2 raised to x minus 1 to 1/2 raised to x, or 1, and then copy the remaining term minus 1. And then plus 1/4. Now let's simplify the exponents. Okay, 1 minus 1 is equal to 0, meaning this one will give us 1/2 raised to 0 plus 1/4. Right now, we have this fraction raised to 1 exponent 0. Okay, so 1/2 raised to 0 is equals to 1. Okay, that's 0.5 in decimal form raised to 0. That's 1. And then copy the remaining term 1/4. This time, we have this the similar fraction. So again, guys, how to add the similar fraction? So LCD lang yan. So again, meron tayong invisible denominator na 1. Okay? So, yeah. So again, we have 4. So 4 divided by 1, that is 4. 4 times 1 is 4. Now do the same thing sa ating second denominator. 4 divided by 4 is 1. 1 times 1 is 1. So we have 4 plus 1. And then let's simplify the numerator and then copy the denominator. 4 plus 1 is equals to 5. And then copy the denominator 4. So meaning this is our final answer. Okay? So that is 5 all over 4. So that's the limit of 1/2 raised to x minus 1 plus 1/4 as x approaches positive 1. Okay, and that's it. So that's again our example for evaluating limits of exponential function. Okay, next one. How about the limits of logarithmic function? Okay, so let's review again the concept of logarithmic function. So recall that logarithmic functions are functions of the form f of x equals to logarithm of x base b. Okay, so guys, same with exponential. Actually, yung concept ni exponential ay connected sa concept ni logarithm. Okay? Because the process, or the again, yung concept mismo ni logarithm, okay, is just an inverse process of exponentiation, no? Kabaligtaran lang siya. Okay, inverse lang siya ng exponentiation. So, pwede nating i-rewrite yung exponential form to logarithmic form, or vice versa. Okay, later reviewin natin yan. Okay? So, the logarithm is the exponent. So for exponential, the base remains the same for logarithm, and the value of x right now, or the answer for this problem, cannot be hindi siya pwedeng maging negative number. Okay? So hindi pwedeng maging negative number. Again, connected nga siya sa concept ni exponential. Okay? So same with exponential functions. If the base right now is e, or Euler's number, guys, meron tayong natural logarithmic function. But instead of writing it as logarithm of x base e, we will use this notation, guys. Okay? ln x, or natural log of x. Okay? Now, due to the properties of the graph of natural logarithmic functions, the following concepts are true. Okay? In terms of its limit, we need to consider the following concepts, guys. Okay? So for positive values of a, the limit of natural log of x as x approaches a is equal to natural log of a. So meaning, guys, pwede tayo mag-apply ng direct substitution. Same with the previous concept. Okay, so limits ng exponential function. Now, how about x approaches 0? Okay, paano kapag i-approach yung positive infinity? And then, one-sided limit kay 0. So, paano naman yun? So, again, the limit of natural log of x as x approaches 0 from the right-hand side, ito, meron tayong positive sign. that's the case, the answer is automatically equal to negative infinity. So, same procedure then, kapag negative naman, okay, or left-hand side, the limit does not exist. Now, if x approaches positive infinity, the answer is positive infinity. Okay? So, this time, open natin ang ating discussion board. So, let's try to solve or evaluate limits of logarithmic functions. Okay? So, let's open our discussion board for limits of logarithmic functions. Alright, so let's try to answer the following examples. Okay? Yan. So examples letter A to F. Now, before tayo mag-proceed sa examples ng evaluating limits of logarithmic function, again, reviewin natin, no? So, ano nga ba yung connection ni exponential to logarithmic function? So, for example, guys, let's say we have this logarithm, okay? For example, logarithm of A base B is equal to C. Okay? So, yan yung logarithmic form. So, pwede mo siyang i-rewrite sa form ng b raised to c is equal to a. Alright? So, ito yung logarithmic form. Ito naman yung exponential form. So, ma-observe natin, same base. Yung base kay exponential, yun din yung base kay logarithmic. Okay? Now, the answer to logarithm, that's the exponent of exponential function or exponential form. And the answer, okay? Yung answer naman kay exponential, yun naman yung number inside the logarithmic form. Yan. So, connected silang dalawa. So, pwede tayo mag-rewrite ng mga logarithmic form to exponential and then, or vice versa. For example, let's say we have 5. Okay? 5, sige, basic example tayo. 5 raised to 2 is equals to 25, right? So, yung corresponding logarithmic form niya, again, let's copy the base. Okay? So, we have this logarithm. Again, what's the answer? That's 25. So, logarithm of 25. Base B, what's the base? The base is 5. And then, what's the exponent? The exponent is 2. So, the answer is equals to 2. Yan. So, that's the logarithmic form of 5 squared equals to 25. So, that's logarithm of 25 base 5 is equals to 2. So, again, another example. Let's say we have, for example, negative exponent. Let's say we have 6, okay, raised to negative 2. So, 6 raised to negative 2, again, if we have negative exponent, we need to reciprocate it, no? Para maging positive yung kanyang sign. So, that's 1 all over 6 squared or 1 all over 36. Yan. So, again, ang corresponding logarithmic form niya, again, that's logarithm of, what's the answer? It's 1 all over 36. And then, what's the base? The base is 6. So, logarithm of 1 all over 36, base 6, is equal, okay, to negative 2. Yan. So, that is equal to negative 2. Okay? Now, this time, let's try to answer the following examples. Okay? Example letter A. So, limit of logarithmic functions. Okay? So, let's evaluate example letter A. Limit of logarithm of x plus 15 base 4 as x approaches positive 1. Okay? Right now, x approaches positive 1. So, according to our presentation, so we are allowed to apply direct substitution. Same with exponential function. Okay? So, guys, dear students, please try to pause, to answer this problem. No? I-pause natin yung video and then later double check natin ang ating solution. Alright, so let's double check our solution, guys. Okay? So, let's apply direct substitution. So, we have this variable x. Okay? So, let's apply direct substitution. So, this one will give us logarithm of x plus 15. So, we have this number 1 plus 15. Okay, and then the base is equals to 4. So, let's simplify. 1 plus 15 is 16. So, meaning this is equal to logarithm of 16 and then base 4. Now, what is the value of logarithm of 16 base 4? Okay? So, to answer this one, you are allowed to use the concept of exponential function. Pwede mo siyang i-rewrite to exponential form. Okay? Or, pwede mo nang i-rewrite yung 16 right now. So, this one will give us logarithm of 16. So, that is equal to 4 squared. And then, copy the base. Alright? So, meaning the answer is equals to 2. And so, this is our final answer. Now, if you want to use the concept of exponential function to answer this problem, so let's rewrite the given expression. So, logarithm of 16 base 4 is equal to, okay, copy the base, the exponent is unknown, and that is equal to 16. Now, what do you think? What is the possible value of x? Okay, wherein the base is 4, and then the answer is equal to 16. So that is equals to 2. Because 4 squared is equal to 16. Or, use the one-to-one property, okay? One-to-one property of exponential function, okay? So we are allowed to rewrite the 16, transform natin siya sa kanyang corresponding exponential form, wherein the base is equals to 4. So this one will give us 4 raised to x equals to, let's rewrite 16, so that's equal to 4 squared. Now, same base, for according to one-to-one property of exponential function, pwede nating equate directly ang kanilang exponent. So, meaning x is equal to 2. Yan. So, it's up to you. You are allowed to use your calculator or use this method, guys. Okay? Next, example letter B. How about limit of logarithm of 2x minus 5 base 2 and then x approaches positive 3. So, guys, i-pause natin ang video and then please try to answer example letter B. Alright, so let's double check your answers, okay? So this is our variable x, so let's apply direct substitution. So again, this one will give us logarithm of 2x or 2 times the value of a, which is 3, and then minus 5, okay, and then the base is equals to 2. Now let's simplify. So this is equal to logarithm of 2 times 3 is 6, and then minus 5 base 2. 6 minus 5 is equals to 1. So we have logarithm of 1 and then the base is 2. Now for logarithms, guys, okay, so logarithm of 1 base 2, regardless kung ano man yung maging value ng ating base right now, okay, as long as yung ating number is equals to 1, automatically the answer is equal to 0. So this is our answer. Or if you want to rewrite the given logarithmic form to its corresponding exponential form, so copy the base, the exponent is unknown, and then the answer is equals to 1, right? So what is the possible value of x or exponent of 2 wherein the evaluated value is 1? So syempre that is 0 because 2 raised to 0 is equals to 1. Okay? So that is our final answer. The answer is equal to 0. Next one. Example letter C. How about the limit of logarithm of 5x minus 7 base 2 and then x approaches positive 3. Okay, limit of logarithm of 5x minus 7 base 2 and then x approaches positive 3. Alright, so let's double check your solution. So let's apply direct substitution. Okay, so here's our variable x. Substitute natin yung ating c or a. The value of a is 3. So this one will give us logarithm of 5x or 5 times 3. Ayan. Substitute lang natin and then minus 7 base 2. Okay? So 5 times 3 is 15. So that's equal to logarithm of 15 minus 7 base 2. 15 minus 7 is equals to 8. So we have logarithm of 8 and then base 2. Now what is the value of logarithm of 8 base 2? Okay? So I think that is equals to 3. Okay, so let's double check. So let's use the concept of exponential function, okay, or exponential form. So let's copy the base. The base is 2, the exponent is unknown, and then the answer is equals to 8. Now let's apply one-to-one property, no? So this one will give us 2 raised to x. So let's transform or rewrite 8. 8 is equal to 2 raised to 3, right? So right now, common base, equate the exponent, meaning x is equals to 3. So this is our final answer. Okay, x is equals to 3. So that's the limit of logarithm of 5x minus 7 base 2 as x approaches 3. Yan. Next, example letter D. Okay? So example letter D. How about limit of logarithm of 3x minus 5 plus 2 base 2 and then x approaches positive 2. Okay, x approaches positive 2. So guys, please try to answer this problem, okay? Alright, so let's check your solution. So let's apply direct substitution. So here's our variable x. Anyways, we have two separate terms right now, ha? Okay? So, simplify muna natin yung nasa parenthesis before i-add yung positive 2. Again, so dito, ipa-follow pa rin natin yung orders of operation. Right, so this one will give us logarithm of 3x. So that's 3 times 2. And minus 5. And then plus 2. The base is 2. Now, let's multiply. 3 times 2. Okay. 3 times 2 is equal to 6. 6 minus 5 is equals to 1. Okay? So, ilagay na agad natin yung value. That's logarithm of 1 plus 2. And then the base is equals to 2. Okay? Now, logarithm of 1 plus 2. Okay, logarithm of 1 base 2 plus 2. Okay, so what's the value again of logarithm of 1 base 2? Okay, again, if the number is equals to 1, meaning the logarithm is equal to 0. So, meaning this will give us 0 and then copy the remaining term plus 2. So, since we have separate terms, okay, right now, separate natin siyang solve. So, meaning the answer is equal to 0 plus 2, the final answer is equals to 2. Yan. Right? Last one. Okay, how about example letter E? Okay, how about logarithms wherein we have this exponent, no, na naka-attach sa ating number. So, limit of logarithm of 2x minus 7 raised to 4 base 3, and then x approaches positive 5. X approaches positive 5. Okay, now, let's apply direct substitution. So, this one will give us logarithm of 2x minus 7. So, that's 2 times 5. And then minus 7 raised to 4. The base is 3. Okay? 2 times 5, simplify natin. 2 times 5 is equals to 10. Okay? And then 10 minus 7 is equals to 3. Okay? Meaning, this one will give us logarithm of 3 raised to 4. And then the base is equal to 3. Actually, right now, no need nang i-simplify yung 3 raised to 4 because if that's the case, guys, automatically the answer is equals to the exponent 4. Yan. So, same yung base at yung number, automatically yung exponent yung magiging answer. Okay, so that is equals to 4. And that's it, okay? So, here's our additional example. Okay? So, guys, again, please try to pause this video and then please try to answer example letter F. Okay, this is I think that's our last example for logarithmic function. All right, so let's double check our solution. Again, limit of logarithm of x squared minus 8x minus 1, wherein x approaches negative 5. Okay, x approaches negative 5. So right now, we have the following variables, x squared and negative 8x. So 2 times tayo mag-substitute. So let's substitute the value of x, okay? So again, this is equal to logarithm of x squared or negative 5 squared. Okay, negative 5 squared minus 8x or negative 8 times negative 5. And then copy the remaining term minus 1. The base is equals to 2. Now, simplify natin. Logarithm of negative 5 squared is 5 times negative 5. That's positive 25. Negative 8 times negative 5. Negative times negative is positive. So, we have positive 40. And then copy the remaining term minus 1. Of course, the base is equal to 2. So, simplify natin. So, 25 plus 40 minus 1. Okay, I think that is equal to 64. Okay, so this one will give us logarithm of 64. And then the base is equals to 2. Now, what is the value of logarithm of 64 base 2? Okay, so pwede natin siyang i-rewrite sa kanyang corresponding exponential form. Okay, so copy the base is 2, the exponent is unknown, and that is equal to 64. Yan. So, i-rewrite natin. Let's apply 1-to-1 property. So, 64. So, if the base is 2, what is the possible exponent? So, I think that is 6. So, let's double check. 2 times 2 is 4. Times 2, 8. Times 2, 16. And 2, 4, 8, 16, 32, and then 64. 1, 2, 3, 4, 5, 6. Yes, so that is our exponent. So, meaning, yan, common base, equate the exponents, x is equal to 6. So, meaning the final answer is equal to 6. So, that's the logarithm of 64 base 2. The answer is equal to 6. And that's it. So, that's the logarithm, or that's the limit of logarithmic function. Okay? So next one, last one tayo. How about the logarithm of trigonometric function? Okay? How about trigonometric function? So check natin yung ating presentation for trigonometric function. Yan. Alright, so for trigonometric function, recall that trigonometric functions are functions based on the unit circle, okay? So we have 6 trigonometric functions. Meron tayong sine, cosine, tangent, cotangent, secant, and cosecant, okay? So meron tayong ginagamit na table to determine the value, okay? Or for example, sine pi all over 2, sine pi, cosine pi, okay? So I want you to use this table, okay, as your guide, okay, sa pag-solve ng limits of trigonometric functions, okay? And we also have this trigonometric identities, okay? So may mga problems na need natin gamitan ng trigonometric identities, okay? So next, of course, we have here the notable special limits, okay, from L'Hopital's rule. Yan, so pwede natin ito magamit sa pag-simplify ng mga limits of trigonometric function, okay? So this time, let's open our discussion board and then let's try to evaluate limits of trigonometric function. Alright, so I have here examples letter A to letter E. And then meron tayong additional examples sa ating presentation. Okay? So let's start with example letter A. So evaluate the limit of trigonometric function. Okay? Example letter A, limit of sine x plus pi all over 2. And then x approaches 0. Okay? X approaches 0. Now, let's apply direct substitution. Okay? And then let's consider some of the trigonometric rules, okay, to solve this problem. Okay, so let's apply direct substitution. So this one will give us, okay, limit of sine x plus pi all over 2, x approaches 0. So let's substitute the value of the constant right now. So this one will give us sine, okay, sine x plus phi, or sine 0 plus pi all over 2. Yan. Now let's simplify. What is the value of 0 plus pi? So that is equal to phi, meaning this one will give us sine pi all over 2. Okay? Now the question is, what is the value of sine pi all over 2? So pi all over 2, so for radian, no, pi is equal to 180 degrees, so meaning pi all over 2 is 90. So sine 90 is equals to 1. And that's it. So this is our final answer. So that's the limit of sine x plus pi all over 2 as x approaches 0. Next, example letter B. So guys, please try to answer example letter B. I-pause natin lang yung video and then i-double check natin ang inyong solution. Alright, so let's double check your solution. So let's evaluate the limit of 2 sine x minus 3 cosine x, wherein x approaches pi. Okay, x approaches pi. So let's apply direct substitution. So this one will give us, again, 2 sine x or 2 sine pi. And 2 sine pi minus 3 cosine x or 3 cosine pi. 3 cosine pi. Okay, now let's evaluate what is the value of sine pi. Okay, so according to our table, okay, trigonometric rule, that is equal to 0. So this will give us 2 times 0. Now, how about cosine pi? What is the value of cosine pi? Cosine pi is equals to negative 1, right? Cosine pi is negative 1. So meaning this one will give us negative 3 times negative 1. Okay, so this is the value of sine pi, and this is the value of cosine pi. Now let's simplify. 2 times 0 is equal to 0. Negative 3 times negative 1 is, again, positive 3. Simplify 0 plus 3, meaning the final answer is equals to 3. So that's the limit of 2 sine x minus 3 cosine x as x approaches pi. Next, example letter C. How about limit of cosine x all over sine x minus 5, wherein x approaches 0? Okay, x approaches 0. Okay? So let's double check our solution. Let's apply direct substitution. So this one will give us, again, cosine x or cosine 0, okay, cosine 0 all over sine x or sine 0 minus 5. So sine 0 and then minus 5. Alright? Now, what is the value of cosine 0? Okay? So cosine 0 is equal to, of course, that's equal to 1. Alright? So that is equals to 1 all over sine 0 is equal to 0. Okay? So copy the remaining term minus 5. So meaning this one will give us 1 all over 0 minus 5 is negative 5. And so meaning the final answer is 1 all over negative 5. So yun na pala yung final answer natin. Okay, so that is equals to 1 all over negative 5. So that's the value of the limit of cosine x all over sine x minus 5 when x approaches 0. Next example. Example letter D. How about limit of 2 cosine x plus 2 as x approaches 3 pi all over 4? Okay, right now x approaches 3 pi all over 4. Now let's double check our solution, guys. Let's apply direct substitution. Okay, so this one will give us again 2 cosine x or 2 cosine 3 pi. Okay, 3 pi all over 4. And then let's copy the remaining term plus 2. Alright? Now, 2 cosine 3 pi all over 4. Now the question is, what is the value of cosine 3 pi all over 4? Okay? Cosine 3 pi all over 4, I think that is equal to negative square root of 2 all over 2, right? So let's rewrite. So again, this one will give us 2 times cosine 3 pi all over 4. Again, that is equal to, that's negative, I think. That's negative. Square root of negative 2 all over 2. Yan. And then copy the remaining term plus 2. Now let's simplify. 2 times negative square root of 2 all over 2. So just cancel out the factor and the denominator. So this one will give us negative square root of 2 plus 2. And that's it. So I think this is our final answer. Okay? So the final answer is negative square root of 2 plus 2, or you are allowed to rewrite this one as 2 minus square root of 2. Yan. So this is our final answer. Next one. Example letter E. I think this is our last example. Okay. Now, limit of 4 sine x plus pi plus 3. And x approaches pi. Okay. So again, please pause this video and then please try to answer example letter E. Again, limit of 4 sine x plus pi plus 3, and then x approaches pi. Alright, so let's double check our solution, okay? So let's start with, again, direct substitution, guys. So this is variable x, so let's plug in pi. So this one will give us 4 sine pi, and then copy the remaining term plus pi, and then plus 3. Ayan. So pi plus pi is equals to 2 pi, right? So meaning that is equals to 4 sine 2 pi, and then copy the remaining term plus 3. Now the question is, what is the value of sine 2 pi? Okay? So sine 2 pi, I think that is equal to 0. Okay? So this one will give us 4 times 0, and then copy the remaining term plus 3. And then this time, let's simplify, okay? So 4 times 0 is 0. And then copy the remaining term plus 3, meaning the final answer is equals to 3. So that's the limit of 4 sine x plus pi plus 3 as x approaches pi. So this is our final answer. Now, how about problems wherein required gamitan ng special limit, okay, from L'Hopital's rule, okay? So I have here additional examples, okay? So example number 1, let's try to evaluate limit of 2 sine x when x approaches pi all over 3. Okay? So, meron din akong additional guides dito, yung table, para guided tayo sa pag-answer ng ating given example. Now, let's apply direct substitution. Okay? So, we have here 2 sine x. So, from sine x to sine pi all over 3. So just apply direct substitution. Okay, simply substitute the value of pi all over 3. Alright? So next, what is the value of sine pi all over 3? So let's check the table. So sine pi all over 3, according to this table, is equal to square root of 3 all over 2, right? So sine pi all over 3 is equal to square root of 3 all over 2. So let's again simplify. So meaning from sine pi all over 3 to square root of 3 all over 2. Now, let's multiply. 2 times square root of 3 all over 2. Again, to save time and effort, just cancel out 2, meaning the final answer is equal to square root of 3. And that's it. So that's the limit of 2 sine x as x approaches pi all over 3. Next, example number 2. So guys, please try to answer example number 2, okay? Now, let's double check your solution. So limit of tangent pi all over 2x, and x approaches positive 2. So here's our variable x. Let's apply direct substitution. So from variable x to positive 2. Now let's simplify. What is the value of pi all over 2 times 2? So just cancel out. So that's 2 pi all over 2, and then 2 pi divided by 2 is equals to pi. Meaning the simplified form is equals to tangent pi. Now the question is, what is the value of tangent pi? Let's check the table. So this is tangent, and this is pi, or 180 in degrees. So tangent pi is equal to 0. So meaning, the final answer is equal to 0. Next, example number 3. Limit of sine x, and then x approaches pi all over 6. Okay? So let's apply direct substitution. So from sine x to sine pi all over 6. Now, simplified na yan, right? So let's check the table. So what do you mean by sine pi all over 6? So this is sine, and then this is pi all over 6. Again, the corresponding value is equals to 1/2, meaning the final answer is equals to 1/2. Alright, next, example number 4. Guys, please try to answer example number 4. Okay, so let's double check your solution. So cosine pi all over 6 times x, and then x approaches negative 3. So same procedure, let's apply direct substitution. So from cosine pi all over 6x to cosine pi all over 6, and then times negative 3. So that's the constant or value of a. Okay, now let's simplify. What is the value of pi all over 6 times negative 3? Okay, so this one will give us negative 3 pi all over 6. So let's simplify this one. This one will give us cosine negative pi all over 2. Okay, because negative 3 all over 6, the simplified form is negative 1/2. Now, what is the value of cosine pi? Okay, cosine negative pi all over 2. So let's check the table. This is cosine, and then pi all over 2, or negative pi all over 2. So that's 0. Okay, so meaning that is our final answer. So that's the limit of cosine pi all over 6x as x approaches negative 3. Next, example number 5. Okay, how about tangent, limit of tangent 2x as x approaches pi all over 4. So guys, please try to answer example number 5. Okay, let's double check our solution. So let's apply direct substitution. So from 2x, or tangent 2x, let's substitute pi all over 4. So this one will give us tangent 2 times pi all over 4. Okay? Now let's simplify. 2 times pi is 2 pi all over 4. The simplified form is tangent, okay, pi all over 2, right? So that's 1/2, or pi all over 2. Now, what is the value of tangent pi all over 2? Let's check the table again. So this is tangent, and then pi all over 2. So the value is undefined. Okay? So if that's the case, again, if that's the case, guys, if the value is undefined, meaning the limit does not exist. Yan. Next, example number 6. So how about problems? Okay, we're in required tayong gumamit ng special limit. Okay? So, example number 6. Limit of sine 5 all over, or 5x all over 6x, and then x approaches 0. Okay? Now, we have here sine 5x all over 6x. Okay? We're in pwede natin i-consider yung ating special limit to solve this problem, okay? So this is our table, okay, from L'Hopital's rule, okay? So pwede nating i-apply right now si special limit number 1 to evaluate the given limit. All right? So we have here sine x all over x, and then that is equal to 1. So meaning we need to factor out 5 all over 6, okay? So this one will give us limit of 5 all over 6 as x approaches 0 times sine x all over x. Again, that is equal to limit of 5 all over 6 as x approaches 0 times limit of sine x all over x as x approaches 0. So again, we need to apply some of the given limit laws to simplify this one. Okay? Now, let's simplify. Let's start with limit of 5 all over 6 as x approaches 0. So this is a constant, okay? So meaning the answer is automatically 5 all over 6. Now, how about this term? How about the limit of sine x all over x as x approaches 0? So let's check the table. Again, that is equals to 1. Meaning, this one will give us 5 all over 6 times 1. Right? So let's simplify. Again, the final answer is equal to 5 all over 6. Next, how about example number 7? Limit of sine 8x all over 2x as x approaches 0. Okay? Now, same rule again, we need to apply the special limit to solve this problem, okay? So we need to factor out 8 all over 2, okay, to simplify this one. This one will give us limit of 8 all over 2, okay, as x approaches 0 times sine x all over x. So again, that is equal to limit of 4 as x approaches 0. So that's a simplified form of 8 all over 2. And times the limit of sine x all over x as x approaches 0. So that is according to the limit laws, okay? Now, what is the value again of limit of 4 as x approaches 0? So that is constant, right? So meaning this term is automatically equals to 4. How about this term? So please check the table. Again, sine x all over x as x approaches 0 is equals to 1. Meaning this one will give us 4 times 1. And the final answer is equals to 4. Next, example number 8. Limit of x squared minus 3 tangent x all over x as x approaches 0. Now, please check the given problem and then check the given the notable special limits from L'Hopital's rule, okay? So what do you think, guys? Anong rule number or special limit ang pwede natin magamit to solve this problem? Alright, that's it. So that's SL or special limit number 3, okay? So according to SL limit or special limit number 3, the limit of tangent x all over x as x approaches 0 is equals to 1. Okay? So meaning to solve this problem, again, let's factor out x squared minus 3. So let's apply the limit laws. This one will give us limit of x squared minus 3 as x approaches 0 times tangent x all over x. Okay? So let's simplify those terms, okay, separately po. So limit of x squared minus 3 as x approaches 0. So this is quadratic, so we need to apply direct substitution. So this one will give us 0 squared minus 3, okay? 0 squared minus 3 is 0 minus 3, so that's negative 3, right? How about this term? How about tangent x all over x? Again, according to this table, that is equals to 1. So meaning, this one will give us, alright, so that's 0 squared minus 3 from this term, and times 1. So let's simplify. So this is equal to negative 3, and then copy the remaining term times 1. So the final answer is equal to negative 3. So that's the limit of x squared minus 3 tangent x all over x as x approaches 0. Next, example number 9. Okay, how about limit of e raised to 2x minus x all over e raised to 2x times x as x approaches 0. Okay? So, again, please check the following terms. Right now, we need to apply SL number 6 to evaluate the given limit. Okay? So, right now, we need to factor out e raised to x. okay? And then apply the limit laws to simplify the given problem, okay? So let's factor out e raised to x to the numerator and denominator, and then apply the limit laws, okay? So limit of e raised to x, I factor out e raised to x, guys, okay? So from e raised to 2x to e raised to x, and then from negative e raised to x to negative 1. Now, please check the denominator from e raised to 2x to e raised to x, and then times x. Alright, so let's cancel out e raised to x. So this is our remaining term, e raised to x minus 1 all over e raised to x times x. So right now we need to eliminate e raised to x, right? So let's factor out e raised to x. Let's apply the limit laws, okay? So this one will give us 1 all over e raised to x as x approaches 0 times the limit of e raised to x minus 1 all over x. Ayan, so right now, pwede na natin magamit si SL number 6 to evaluate the given limit. Now the question is, what is the value of limit of 1 all over e raised to x as x approaches 0? So let's apply direct substitution to solve this one, okay? So again, anyways, this term is automatically equals to positive 1 according to SL number 6, okay? Now this term is equal to 1 all over e raised to 0 if you apply direct substitution. Now 1 all over e raised to 0, so e raised to 0 is equals to 1, right? And then this term is equals to 1, so meaning this one will give us 1 and then times 1. Okay, again, 1 all over e raised to 0 is equals to 1 all over 1. And 1 all over 1 is equals to 1. And then times 1, that's the remaining term. So the final answer is 1 times 1. The answer is equals to 1. So that's the limit of e raised to 2x minus e raised to x all over e raised to 2x times x as x approaches 0. Next, example number 10. How about limit of 1 minus cosine 2x all over 4x as x approaches 0? Okay? So to answer this problem, okay, please check the following terms right now. We need to apply SL number 2, or special limit number 2 from L'Hopital's rule to evaluate the limit. Okay? So according to SL number 2, we have 1 minus cosine x all over x. Again, if x approaches 0, that is automatically equal to 0. So right now, we need to factor out 2 and 4. Alright, so let's apply the limit laws. So this one will give us limit of 2 all over 4 as x approaches 0 times the limit of 1 minus cosine x all over x. Okay, right now guys, 2 all over 4 is a constant. So again, that is automatically the value of limit of 2 all over 4 as x approaches 0. So that's 2 all over 4. And then this time, this term, according to SL number 2, is equal to 0. Meaning, this one will give us 2 all over 4 times 0. And the answer is equal to 0. Last one. Guys, please try to answer our example number 11. So please pause this video and then double check your solution. Alright, so let's double check your solution. So what's the limit of x plus sine x all over x as x approaches 0? Okay, so again guys, x plus sine x all over x. Right now, we have this plus, okay? This is plus x, okay? So yes, we need to apply SL number 1 to evaluate this limit. But this time, again guys, this number is added to sine x. Okay, so we are not allowed to apply factoring, okay? Pero, pwede pa rin natin gamitin yung ating limit laws. Alright? So this one will give us limit of x all over x as x approaches 0 plus limit of sine x all over x, okay, when x approaches 0. Now sir, bakit po addition? Okay, so again, x all over x is automatically equals to 1. Alright, so just consider the rule, okay, for fraction, okay? So we need to consider the denominator or LCD, okay? So you're allowed to use 1, okay, or x all over x, okay? Same na magiging term. Alright, so if you want to double check your answer, so just add this number and then sine x all over x. So this one will give us, again, the LCD is x. X divided by 1 is x. 1 times x is x. Plus x divided by the denominator of this one, which is x. So that's 1. 1 times sine x is sine x. So meaning, if you simplify this term, the result is x plus sine x all over x. Okay? Now, Let's apply the limit laws that simplify as 1. Limit of 1 as x approaches 0. This is equals to 1. Okay? Now, how about this term? According to SL number 1, that is equals to 1. Meaning, 1 plus 1 is equals to 2. So that is our final answer. And that's it. So that's the limit of exponential function, logarithmic function, and trigonometric function. Thank you guys, and God bless everyone.